N2 plus 2H2O. All are in gaseous state. All are in gaseous state. See, following data is obtained. Following data is obtained. Data is obtained. That is concentration of NO, concentration of H2 minus 1 by 2 into change in concentration of NO by change in time. Change in concentration of NO by change in time. See, it is 5 into 10 power minus 3. It is 2.5 into 10 power minus 3. It is experiment 1, and here it is 1 into 10 power minus 3. 3 into 10 power minus 3, which is 1.5 into 10 power 15 into 10 power minus 3 into 2.5 into 10 power minus 3, and it is 9 into 10 power minus 3, 10 power minus 3, 15 into 1 10 power minus 3, and here 10 into 10 power minus 3, it is 36 into 10 power minus 3. See, in an experiment 1, when the concentration of NO is 5 into 10 power minus 3 and the reactant H2 is 2.5 into 10 power minus 3 and the rate is 3 into 10 power minus 3. In experiment 2, when the concentration of NO is 1.5 into 10 power minus 3 and the concentration of H2 is 2.5 into 10 power minus 3 and the rate becomes 9 into 10 power minus 3. So these are the experiment 1, experiment 1, experiment 2 and the experiment 3, 3 experiments. Okay, so here in this equation, if you observe this, it is nothing but rate of reaction of minus 1 by 2 into minus 1 by 2 into change in concentration of NO by change in time is nothing but rate of reaction. Okay, now to solve this equation, that is to solve this problem, we have two methods. One is by writing the rate law expression. By assuming the rate law expression, we can solve. That is the method we have to solve here. See once. Rate law for this equation is rate of reaction equal to K into concentration of NO power X into concentration of H2 power Y. Okay, it is the general equation. Sorry, it is the rate law for this equation, for this reaction. Okay, now substitute one by one data, one by one experiment in this equation and solve that equations. We will get X values and Y values. That means we will get the order of X value and Y value. See one. And substituting the experiment 1. See, in experiment 1, what is the rate of reaction? 3 into 10 power minus 3. 3 into 10 power minus 3 into K. NO. Concentration of NO is 5 into 10 power minus 3 whole power X. And concentration of H2 is 2.5 into 10 power minus 3 whole power Y. Take it as 1. And then the next equation 2, substituting the experiment 2 in this equation, 1.5 into 10 power minus 3 equal to K into is now 1.5 is 15. 15. 15 into 10 power minus 3 whole power x. 15 into whole power minus 15 into 10 power minus 3 whole power x. 2.5 into 10 power minus 3 whole power y. Sorry, here rate is, for this one rate is 9 into 10 power minus 3. Take it as 2. Next third one, I am substituting third experiment in the equation. Rate becomes 36 into 10 power minus 3 equal to k into 15 into 10 power minus 3 whole power x, and 10 into 10 power minus 3 whole power y is the 3. See, if you observe these equations, in this equation, if we compare 1 and 2, in these two equations, the concentration of H2 is constant. 2.5 into 10 power minus 3. Here also 2.5 into 10 power 2.5 into 10 power minus 3. So on dividing 1 and 2, 1 by 2, on dividing equation 1 by equation 2, what we get? 10 power minus 3, 10 power minus 3 cancel, and 9 by 3, how much? 3 equal to k cancel, and 15 into 10 power minus 3 whole power x. Here 5 into 10 power minus 3 whole power x. Okay, and this one getting cancelled. Therefore, 5 into 10 power minus 3, 5 into 10 power minus 3, 10 power minus 3, 10 power minus 3x cancel. So 15 by 5. 15 by 5 means how much you get? 5. 15 by 5. How much you get? 3 power x. Therefore, bases are equal. So power should be added now. X equal to 1. X equal to how much? 1 will get. Next, on equating equation 2 by 3. Why you are taking like that means, if you observe the equation 2 and 3, in equation 2 and 3, the concentration of the reactant NO is constant. These values are constant, same. So on dividing 2 by 3, these two values are getting cancelled. We will get a y value. See how that. Equation 2 by equation 3. What we will get? 9 into 10 power minus 3 by 36. 9 by 36, 10 power minus 3, 10 power minus 3 getting cancelled. Then 9 by 36, how much? 1 by 4 equal to, these two are getting cancelled. So 2.5 into 10 power minus 3, 10 power minus 3 power y, 10 power minus 3 power y, both are cancelled. 2.5 by 10. 2.5 by 10 means 2.5 in 10, 4 times it cancel. So 1 by 4 power y. This will gives 4 power 1 into 4 power y, which indicates y equal to 1. Therefore, order of a reaction, that means that is x value is 1, y value is 1. Substitute in the general rate equation. So general rate equation is rate of reaction becomes k into concentration of A power NO power 1 H2 power 1. That means see, rate of reaction equal to k into NO power 1 and H2 power 1. Therefore, it is the rate law. Expression. Okay. Now, that is the rate law expression. Now, overall order of reaction, nothing but order of reaction. That is 1 plus 1, that is 2. So first of all, we forgot one question here. See, this is the data given, and find rate law and order of the above reaction. Therefore, you calculate in rate law is this one, and order of the above reaction is 2. That is the experimental determination of order and rate law concept. Okay, now I will give one example, one problem. You solve that. For the reaction between NO and Cl2, N1Cl2, to form NOCl, following data is given. Following data is given. Okay, see the data. Concentration of Cl2, concentration of NO, initial rate, concentration of, when concentration of Cl2 is 0.05 molar, and when concentration of NO is 0.05 molar, initial rate is 1 into 10 power minus 3. When the concentration of Cl2 is 0.15 molar, when concentration of NO is 0.5 molar, then initial rate becomes 3 into 10 power minus 3. The concentration of Cl2 is 0.05 and it is 0.15 molar. Initial rate becomes 9 into 10 power minus 3. Okay, calculate 1 order of reaction and 2 value of rate constant. Okay, just to find it. And rate law expression. Okay, rate law expression. Okay, calculate this 3. So we solved in the previous problem, same model. Okay, so only extra thing is value of rate constant. So after getting the rate law, first we will get the rate law. Okay, from that we will get order of the reaction. Okay, after that value of rate constant we have to calculate. We will get general equation. We have to assume the general equation like this now. Rate equal to K into concentration of NO power some x, Cl2 power some y. Now after getting these values, we will get some values will get now, like some 1, some 2, like that we will get now. Okay, so after getting that, here substitute one experiment data completely here. That means if initial rate is 1 into 10 power minus 3 and the concentration of NO is 0.05 and Cl2 is 0.05, and here these two are given now, powers also will get. So after getting that we will get answer and calculating. From this we will get K value. You can calculate the K value. Okay. Now see units of rate constant. Okay. Very important concept for NEET and PUC. See units of rate constant. Okay. So for this, we have to assume some general equation. Reactant R gives products. Okay, for this, suppose for this rate equal to K into concentration of R power n, where n is the where n is order of reaction, where n is the order of reaction. So here from this, if you take this equation, what are the units of rate? Units of rate we are already studied, that is mole liter power minus 1, because rate means nothing but change in concentration by change in time now. Okay, so concentration change in concentration by change in time now, therefore rate equal to mole liter inverse second inverse into K equal to, where R is the concentration term, concentration term means its units of concentration term is mole liter power minus 1 whole power n, that means whole power n. See, units of rate is mole liter inverse second inverse K into, it is a concentration units is mole per liter. Okay, mole liter inverse whole power n. Therefore if you see, if we modify this is the mole liter inverse. Okay, it is the mole liter inverse whole power n. Therefore mole liter inverse by mole liter inverse whole power n into second inverse equal to K. Therefore you take it as power 1, then mole liter inverse whole power, how much will get 1 minus n into second inverse equal to K. Therefore units of K for nth order reaction is equal to mole liter inverse whole power 1 minus n second inverse. Okay, and finally on modifying this, what you will get, see once, units of K for nth order equal to mole power 1 minus n liter power minus of 1 minus n into second inverse. Minus of 1 minus n means I will get as liter power n minus 1. Okay, liter power n minus 1. Okay, so if order is, if n equal to 0 means, zero order. For zero order, units of K units equal to, for n equal to 0 means zero order, units of K equal to mole liter inverse second inverse. If n equal to 1, that is first order, units of K equal to, if n equal to 1, means mole power 1 minus 1 0, liter power 1 minus 1 0, second inverse. Then units is mole power 0, liter power 0, second inverse, which is second inverse. Okay, if n equal to 3, means, that is, sorry, n equal to 2, then which is second order. For second order, units of K equal to mole power 1 minus 2, that is how much, n value 2 na, second order means n equal to 2, mole power 1 minus 2, that is mole per minus 1, later power 2 minus 1, that is later or second inverse. So these are the units of rate constant for different orders. Okay, for various orders, these are the units of rate constant. Okay, so the units of rate constant concept is very important. It's very important for NEET and PUC. NEET level and PUC, it's very important concept. It is very important concept.